Okay, facts stored in fact table. There is a separate table which stores all these facts. Now, if you remember, in a traditional relational database, we don't use a term called facts and dimension. We use a term called tables, and we never distinguish the information in terms of facts. The way we distinguish the information in terms of entities. So maybe I've got one entity for customer, which talk about all customer information. Generally in transaction system, if you say the customer, customer information is stored across many tables. Customer, correspondence, customer history, okay, customer personal info. So same information, the customer information is stored in multiple tables, right? Because the transactional model. Whereas if I design dimension model, customer should be stored in a single table. So we have a customer dimension underscore customer. It's a OLAP model. In a simple word, we are denormalizing all this information into a single table. Why do we do normalization? In order to support insert and update operation, right? Whereas in a data warehousing, most of my queries are select queries, or it is used for data analysis. So if you look, all the requirements I analyzed all consist of data retrieval or reporting. So we don't need an insert and update operation. So the information we store in terms of facts and dimension. What fact consists of? All numerics. Let's see an example of fact. This is one of my model. I've got two fact tables. We'll take this model and go step by step way to analyze, correlate with the business requirement, finally build our solution. So in this example, you can see the tables are organized in terms of facts and dimension. What fact table consists of? My fact table consists of foreign keys. You can see product ID is a foreign key for product dimension table. Customer ID is a foreign key for customer table. Therefore, my fact table consists of foreign keys with respect to various dimensions and numeric facts, right? Advertisement cost, unit cost, sale tax, road tax, all these are. And all these numerics or facts, we eventually perform the calculation analysis. So if you go all requirement 1, what fact you need? Amount sold. Requirement 2, what fact you need? Sales and growth percent. Requirement 3, what fact you need? Average customer sales. Requirement 4, what fact you need? Promotion cost for each promotion channel and the sales cost, sales. Requirement 5th, what information you need? Projected versus actual sales. So forecast sales, the sales which company has forecasted, maybe 2013, next year we forecast some sales and actual sales. So all the requirements essentially have the facts associated with this. I've shown you a very pretty simple example. If when you work for a client, there are hundreds of reports. One of my requirement, they have close to 213 reporting requirements. And most of the requirements are designed for financial closing. And let me tell you once again, we are pretty specialized in financial domain with respect to BI. So this is what your fact is. Fact table consists of what? Fact table has fact table has facts, numeric and foreign keys. So it's a central table. Often it's a central table. If you look at my model, it is a central table which is surrounded by dimensions. So in simple word, if you look at one dimension, one fact, what does that mean? If I look at product category and sales, what it says, total sales amount sold for one product category, if you look at this intersection. Whereas if I say customer and sales received from one customer from one province of where the customer lives. If you look at the intersection with time and amount sold, total sales done in one day or in one quarter. If you look at the intersection with sales and channel, we say total sales received from channel class, direct or online sales, promotion versus what is the promotion cost and how much sales has been increased as a result of promotion, and finally customer. So if you see, the moment when I take the intersection of any of the dimension with fact, it brings certain meaning to me. Therefore fact have to be a central dimension. Generally raw, narrow and few column. It's very narrow and very huge. Very huge. You know why it's very huge? Look at this. So I'm trying to create, this is my transactional table for fact. So let's say this is my, I take only 4 column called fact, sales. Okay. So the first column is called customer name, date, customer name, product name. I make it very simple. Basically product name would be a product ID. All facts are there, customer ID, and finally time ID, and finally your sales amount. So imagine one day, let's say today is 7th January, so my time ID is 7th 01/2012. This is my time ID, which one customer, there's one customer ID, some product he bought of 100,000, right? So if there are 100,000 transaction per day, I assume the lowest, the granularity of data we are managing every day transaction. There are 100,000 transaction per day, and so how many rows are there? There should be 100,000 rows. For each transaction there is one row. The same day, customer 1, so similarly you would have 100,000 transaction for their one day, there are 100,000 transaction. If I'm managing this fact table for 3 years, so 3 years transaction, you can calculate it, 100,000 into 31 days into 365 into 3 years. These many transactions you have, these many rows you have in your transaction table just for 3 years. 3-year transaction would have number of rows. So you see the volume of the fact tables is often very huge. It's very lengthy. These many rows you have for 3-year data. In case you are managing everyday details, day wise, it is very narrow. Fact table definition we discussed. What it consists of? It consists of foreign keys and facts. So the first thing when you start analyzing, you identify what are the various facts, logically group them and create fact table. The same thing I did when I analyzed the requirement. I split the facts into two pieces, all the things related to sales and all the facts related to the cost price of the product. So similarly, there may be need of segregating. Ideally, this is a data modeler job. So the better you understand business data, the better you can create a query and design the reporting solution. In order to work in business intelligence, it's good to know some bits and pieces about your business information. That's your fact. Okay, what is dimension? We discussed dimension, qualifying characteristics that provide additional view or prospect of a given fact. Same fact, my fact is same, sales is one fact, but what are the various views? View 1 is quarter. So when I look at time versus fact, it says quarterly sales. When I look at another dimension called province, and the fact is same. So fact is same. So first view, time intersection with fact, which is quarter 1 sales, right? Second view, we look at another intersection, sales manager intersection with fact. With fact is your sales. So example, John, the sales manager, and my fact is sales. View third, store type, intersection with fact, sales. So online store, sales. Now if you see each intersection, the fact is remain same. Fact is same, whereas only the view is getting changed. Dimension is getting changed. Here it is time, here is sales manager, here it is store. The fact is same, but we are looking the same fact from various intersection. That's what it says. Provide additional perspective to a given fact. All the dimensions are stored in a table called dimension table. Okay, so this is dimension table and a fact. What a dimension table consists of? Dimension table consists of dimension. Let's take an example for product. Product dimensions consist of all the information related to the product. Primary key and various information of the product. This is your dimension table. Generally, when we move from transactional model to transactional model to OLAP model or multidimensional model, we denormalize this information. So in this model, there are more than one table which store customer information, customer mailing address, customer city, customer street address, customer metropolitan city, postal code, country, there are various tables. But eventually, when I convert into multidimensional model, we join all these tables, we denormalize and convert one common customer table. This is the customer table I have taken from there itself. They got province information, city, whatever, all information, all required information needed for data analysis. I join them and convert into this way. So dimension table is produced as a result of, there may be as a result of denormalizing multiple tables into a common dimension. And that's a true example of it. And many flag tables are applied. We apply some Informatica tool to convert into one common table. So dimension is one integrated which talk about one subject area, one subject area, like customer dimension, one subject area is customer, product dimension, one subject area is product. Ideally, it should be like this. So star schema, as its name indicate, it look like a star, and there is